So since we have made all the videos about the turning effects of forces, which included concepts like calculating the moment of a force, about a pivot, finding the center of gravity, and locating the force, which is the weight of any object, learning about the principle of moments and applying it to solve problems, and both conditions of equilibrium. Now we need to apply all those concepts to solve few example problems, and for that I have picked out a few problems from some books, and I'm gonna be solving those examples in front of you. So let's read the first example, which says if a uniform bar balances as on the left. Now it's important to underline each and every important part of the problem, and you will always see me do that because that really helps you understand some of the hidden information in the question. So if the bar is uniform, that basically tells you that the center of gravity of the bar is at its center. Okay. The bar is balanced. So if the bar balances, you know that you can apply the principle of moments to this bar since it is balanced and the clockwise and anti-clockwise moments are equal on this bar. It has a mass attached to it, which is 1.5 kg. Now they're asking what is the weight of the bar itself, and they've given you the value of g, which you're supposed to remember is 10 on earth. Now you can look at the bar and it is balanced, so there must be it must be applicable to basically the principle of moments must be applicable on this situation, which is sum of anti-clockwise moments should be equal to sum of clockwise moments. Now the first thing that you need to realize is where the weight of the bar is going to be. Well, since we have already highlighted the center of gravity, that's where the weight of the bar is going to be. Another force which is acting on the bar is obviously because of this mass which is hanging here. Now the first thing to realize is that you have been given the mass, not the force. So in order to find moments, you should turn this into force, and that is the weight of this particular object. So since this object is 1.5 kg, you can find the weight using the equation mass times gravity, which is going to be 1.5 multiplied by 10. That gives us 15 Newton. So this force here is 15 Newton. Now this weight on the left is going to apply an anti-clockwise moment, so we can say 15 multiplied by 0.2, and there is no other anti-clockwise moment. We are using point O as our pivot, so we can move on to the right hand side of the equation. The weight, which is not known right now, so we're just gonna write it as W in the equation, is how far away is it from the pivot. So this is the distance that you need to figure out. Well, we know that the weight is right in the center of the beam, and since the beam is 1 meter long, it means that from the left hand side that distance is 0.5. Now if that distance is 0.5 from the left, and if you subtract 0.2 from it, you will get 0.3 meters. So that means that weight should be multiplied by 0.3 meters, and using this equation you can find out the value of W, which will be 15 multiplied by 0.2 divided by 0.3. So 15 into 0.2 will be 3 divided by 0.3. So weight has turned out to be 10 Newton, and that is the answer to our question. Let's move to the second problem. Now it says below on the right, someone has a weight of 500 Newton. As shown on the diagram, the person standing on the plank has a weight of 500 Newton. It's supported by two trestles, and they're saying calculate the upward forces X and Y applied by the trestles on the plank. And they're saying that the plank itself has a negligible weight, so we can ignore the weight of the plank in this question, you have to read the question carefully to understand if you need to ignore the weight of the plank or you need to include it. If they're not stating anything and if they're giving you the mass or the weight of the plank, then that's a hint for you to take it into account. Otherwise, you can ignore it if they have explicitly stated that you can ignore the weight of the plank. Now, we need to realize that this situation basically needs us to apply both the conditions of equilibrium. Why? Because first of all, the plank is not moving, it's stationary. So it must be that upward forces, it must be true that upward forces on the plank must be equal to downward forces on the plank. So this means that force X and Y, which are added together since they are both facing upwards, should be equal to the downward force, which is 500 Newton. Now, when you apply this condition, you find out that there are two unknowns in this equation. Both X and Y are unknown, and you can't find them out from a single equation. So you need to make another equation, and you have to do that using the other condition of equilibrium. Now you also need to realize that this plank is balanced. It's not rotating, it's not falling to one side, which means that clockwise and anti-clockwise moments are also equal in this situation. So we can say again, sum of clockwise moments should be equal to anti-clockwise moments. This is the other condition of equilibrium, and for that, the first thing that you need to do is realize that you need to pick the pivot yourself, and it's up to you. If it's not stated in the question, then you can pick any sensible point as the pivot, but it is always useful to take that point as the pivot where there is a force acting and that force is not known, the force is not given to you. For this particular problem, that point can either be A or it can either be B. Both of them are acceptable, since in both of these positions there are forces X and Y which you don't know. And why this is useful, we'll just find it out. Let's just first take point A as the pivot. So let's take point A as our pivot, and now take the moments about this point and then make an equation. So you can see about point A there is a 500 Newton force which is 2 meters from it, and that applies a clockwise moment. So I can say 500 multiplied by 2 meters, that applies a clockwise moment. You can see that force Y will produce an anti-clockwise rotation if you take point A as the pivot. So force Y will have to be multiplied by the distance from the pivot. Now remember, this is 2 and this is 3. If you add these together, you get 5. So Y is 5 meters away from the pivot. Now what about the force X? Why haven't I included that into the equation? Well, for that you need to ask yourself, how far away is force X from point A? Right, so force X is acting right on the pivot. The line of action of this force is actually passing through the pivot, or you can say that the distance between the pivot and the force is 0. Hence, the moment is also going to be 0. So even if you include the force X on either side of this equation, you have to multiply it by 0. So because it does not produce any moment, the distance is 0. That is why we don't need to include force X in this equation, and that is the advantage of choosing that point as the pivot where you don't know the force yet. Now you can realize that the equation 2 is basically just it just has one unknown, so you can find that unknown Y from this equation, and then you can substitute the value of Y in equation 1, and that will be it. That will be the end of the problem. So let's solve this equation. Well, 500 multiplied by 2 is 1000, and if you divide it by 5, Y turns out to be, I think, 200. Yes. So y is 200. Don't forget the unit. So this is the first answer. Now you can go back to equation 1 and easily solve this problem. This y is now known to us. We know that it's 500. So you can write the second equation and find x from it. So x is unknown, but y is 500. Y is, sorry, 200, and the right hand side was equal to 500. So x will be 500 minus 200, and that is 300 Newton. That's it. We have solved this problem as well. Now here is a bunch of questions from the same book, Fundamentals of Physics, published by Oxford Publishers, and we can take a look at some of these questions as well. So the first question asks, the turning effect of a force depends on two factors. What are they? Well, for that you just have to look at what is the force, what is the unit of the moment. Well, moment is equal to force times distance. So basically the answer is force and distance. The answer to question 1 is that the two factors are the force, the size of the force, and the size of the distance, nothing else. And the bigger each of them are, the bigger the moment is going to get. Now the question to ask, what is the principle of moments? What other rule also applies if an object is in equilibrium? So this question is basically asking you what are the two conditions of equilibrium. One of them is the principle of moments, and the other one is that forces in one direction must be equal to the forces in the opposite direction. And for that you can watch my previous video, which is exactly on this topic, and you should memorize those two statements and understand them as well, because we are using them to solve questions, but you need to also memorize them because you might be asked in the exam to write them, and for that you should get all the keywords right. That is why it is always advisable to learn your definitions, your laws and your rules, so that you don't get them wrong in the exam. Now question number 3 is a problem which says someone is trying to balance a plank with stones. Alright, so here they are trying to balance. The plank has negligible weight. Alright, so we can ignore the plank's own weight. Calculate the moment of 4 Newton about O. So you have to use point O as your pivot. Let's remember that this is our pivot. And for part A of question 3, we are just required to calculate the moment of 4 Newton force about the point O. So this is the 4 Newton force, and it's 4 meters away from the pivot. So that will be just force into distance, 4 into 4, and that should give us 16 Newton meters. Now part B says calculate the moment of 6 Newton force about point O. Well, again 6 Newton force is there, and it's 2 meters away from the pivot, so you just have to multiply it by 2 and you will get 12 Newton meters. Now remember that this 4 Newton force is going to apply a clockwise moment, and this 6 Newton force is going to apply an anti-clockwise moment. What is the part C asking? Part C says, will the plank balance? If not, which way will it tip? Well, you know, for the plank to balance, clockwise moment and anti-clockwise moment must be equal, but we can see that clockwise and anti-clockwise moment are not equal to each other, so it will not balance. And which way will it tip? Well, it will tip in the direction where the moment is bigger. So the clockwise moment is larger, that is why it will tilt clockwise. All right. Now, what is part D of this question asking? They're asking what extra force is needed at point P to balance the plank. So remember, this is point P. Let me just mark it for you. I've made a red dot there, and they're asking what extra force is needed to balance the plank. Well, let's assume there is a force acting on the plank at point P. Right now, the problem is that we don't even know the direction of that force. So we have to figure out the direction as well. Uh, Now think about it. If you want to balance the plank, do you need some more anti-clockwise moment or do you need some more clockwise moment? Right now the situation is that clockwise moment is larger than anti-clockwise moment. So there must be some more anti-clockwise moment needed in order to balance the plank. And for that, the direction of the force must be downwards. This is the direction of the force that will produce an anti-clockwise moment. Now the question asks, what should be the size of this force at point P? Well, again, you just need to apply the principle of moments here, which is clockwise moments should be equal to anti-clockwise moments. Now we have already found out the clockwise moment, which is 16. There is no other force which is applying a clockwise moment, so we can move to the right hand side of the equation. The 6 Newton force applied a clockwise moment of anti-clockwise moment of 12 Newton meter. Now the blue force, the force which is acting at P, is not known, so we don't know the force, so we'll just call it F. Let's just call this force F. But we do know that this point P is 4 meters away from the pivot. So let's solve this equation to find out the value of F. Well, 16 minus 12 is going to be 4, and then you can take 4 on the left hand side, so just divide 4 there, and F therefore will turn out to be equal to 1 Newton. So this is how big it should be in order to make the plank balanced. Now part E asks, in which direction must the force P act? Well, I think they should have asked this question first, because even if you have to find out the size of force P, you must first know its direction. So we have already figured it out in the question that the direction of the force must be downwards. So the answer to part E will be downwards. Alright, let's look at the last question for this video, which is question 4. Now it says the diagram on the opposite page. Well, I've copied that diagram, and this is the diagram that we will be looking at, the picture below. Part A asks, what is the upward force from the support? Well, first of all, let's see how many forces are actually acting on this box. The forces are a 10 Newton weight, an 8 Newton weight, and a 3 Newton weight, all acting downwards. And the upward force has to be equal to that, because this beam is balanced and this beam is also stationary. So in order for it to not fall down or fly upwards, in order for the beam to stay in its place, the upward forces and downward forces must be equal to each other. So you can just apply the condition of equilibrium, which is upward force should be equal to downward force, and all the downward forces are 10 plus 8 plus 3. So what we end up with is 10 plus 8, 18, 18 plus 3, and 21 Newton. So that should be the answer to this question. Now part B asks, if moments are taken about P, so this is important, they want us to take the moments about point P, take point P as the pivot. Let's mark it here with red. Which forces have clockwise moments? What is the total clockwise moment about P? So the forces that will apply a clockwise moment about P will be this 10 Newton force, this 8 Newton force and this 3 Newton force. All of these forces will apply a clockwise moment if the pivot is at P. So the forces are 8 Newton force, 10 Newton force and 3 Newton force. And what will be the total clockwise moment? Well, we can find that out because we have all the distances and all the forces available. So the 10 Newton force is 2 meters from point P. Let's make that distance clear on the diagram. 10 into 2 plus the 8 Newton force is 4 plus 1, 5 meters away from it. So that will be 8 multiplied by 5. And then the 3 Newton force is 8 meters away from it. So 3 multiplied by 8. And all we have to do is just find out these moments and add them up together, which should give us 10 into 2 plus 8 into 5 plus 3 into 8, and that will be 84 Newton meter. That is the total clockwise moment. Part C asks which forces apply anti-clockwise moment about P. Again, if you take P as the pivot, which force is applying the clockwise moment, the anti-clockwise moment? And by looking at the diagram, it's pretty clear that this is the force. This force at point O is the one which is going to apply an anti-clockwise moment. So we can write in our answer 21 Newton force at point O. Alright, what is the last? And they were also asked what is the total anti-clockwise moment? Well, again, how do you calculate the moment? You just take the force and the distance from the pivot, which is 4, and that also gives us 84 Newton meter. Last part asks, comparing moments about P, does the principle of moments apply? Well, yes, because anti-clockwise moments are all equal to clockwise moments. Both the clockwise moments and anti-clockwise moments are equal. That is why the principle of moment must apply here. So I'll be solving some more problems in the next video. I will just name this video part 1 and the other video part 2. I'll see you in the next video.